Okay, welcome everyone. This is 15.3 in your integrated 2 textbook on triangle inequalities. The objective for today is how can you use inequalities to describe the relationships among the sides and the angles of a triangle. So we're talking about a triangle, right? And specifically about the sides and the angles and their relationships. Okay, so we're gonna get started with this. This segment here is 2 inches long. Okay, I got a ruler, mapped out 2 inches, and I drew this segment. 1 inch and 3 inches. Okay. So the question for you that I have is, can you make a triangle using these 3 segments? Take a second to think about it. Can you use these segments and these lengths to make a triangle? 1 for yes, 2 for no. 1, yes, you can. 2, no, you cannot. So can you make a triangle using these segments? No, the answer is no, because if I have a 1 inch and a 2 inch and I put them together, right? What's 1 plus 2? What is 1 plus 2, class? 3, right? Yeah, so I put these two together. This is the 1, right? I'm not gonna, and this is the 2 inch, correct? And if my third side is 3 inches, I'm just gonna copy and paste it, correct? Yeah, that's the best that I can do right there. That make sense? Yeah. So in order for a triangle to have that space in between, let's say I draw like a thinnest triangle that I can. Yeah, in order for the triangle to have this space in between, right? These two sides, the sum of these two sides must be greater than this third side. Yeah. Does that make sense, class? Yeah. Okay. If this is 1, the question was, what if the 1 inch was the base? Yeah. Okay. If that's 1, I'm going to go with the 3. Let's say that this is 3. Or let me make the thinnest possible without making it look too thin. Okay. That's 3, right? Look. This is 2.1 inch. If you guys can believe me, because you guys can't see it on the screen. But this right here is 2.1. Literally. It's like right here on my. Yeah, it's 2.1. Right? So 2.1 plus 1 is greater than 3. That make sense? So in order for me, going back to this triangle, in order for a triangle to have a space in between, right? All 3 sides, any 2 sides of the triangle must be greater than the third to make that little puff. If you guys think of like pastries and if you guys put it in the oven, right? To make that little puff and that little space in between, right? Okay. Questions on that? No? So this leads me to my triangle inequality theorem, okay? That the sum of any two sides of a triangle has to be greater than the third. So if I have a triangle like this, ABC, then I know that AB, right, this side, plus BC must be greater than AC. AB plus AC needs to be greater than BC. And then the last inequality that we have is AC plus BC needs to be greater than AB. Okay? Or if you guys want to think about it, the sum of the two smaller sides must be greater than the longest. Okay? All right? Because if we just check this, then every single inequality here will be fulfilled. All right? As long as the two smaller sides is greater than the third, you're good. Okay? All right. So here are some examples. Using the triangle inequality theorem, can these side lengths make a triangle? First, I'm gonna just show you guys all three, and then I'm gonna cut it down to one. All right. So I can say, so if I have these side lengths of 4, 8, and 10, 4 plus 8 must be greater than 10, which it is because 12 is greater than 10. Check. 4 plus 10 must be greater than 8, which it is. 14 is greater than 8. Check. And then 8 plus 10 must be greater than 4, which it is. 18 is greater than 4. Check. Right? So I used triangle inequality theorem, right? Got the sum of any two sides of the triangle. It must be greater than the third. And I checked all three inequalities. But you guys can you guys see that if I just check this one here, right? If I just check this one here and this one is true, I know that everything else will be true. Okay? Because this one, you're adding 2 more than I have here, right? 4 plus 8 and 4 plus 10, right? And this one is just, you're comparing it to the smallest side. So of course, it's going to be true, right? Furthermore, your right-hand side of the equation, you have the longest side here in what I have in boxed in green, right? So the two smaller sides must be greater than the third. Yeah, the longest side. And these are just variations from that. So as long as you guys just check this, you guys should be good. Right? Okay. So for part B, my smallest side, my biggest side, my longest side is 18. So it must be greater than 18. 7 plus 9. What is 7 plus 9? That is 16. Is not greater, right? 16 is not greater than 18. So this is a no. This is a yes. A was a yes. B was a no. 4, 12, and 7, or 12, 4, and 7. My longest side is 12, so I know it goes to the right-hand side. So the sum of 4 and 7 needs to be greater than 12 to make that little puff, which is 11 is greater than 12. No, so no. That makes sense? Okay. 8, 30, and 24. 30 is my longest side. 8 plus 24. That's what? 32 is greater than 30. Yes. So it's a yes. Okay. Does that idea make sense, class? Yeah. All right. So that is the triangle inequality theorem. And now, number 2, or this is the second type of examples. We're going to find the range of values for this third side x. Okay, we're given 10 and we're given 12. What is the range of numbers that x can be? Okay, so if I use that triangle inequality theorem again, and if I label this as my smallest side, okay, let's say that's my smallest side, right? Because the range of numbers is going to be, it's x is either going to be the smallest side or x is going to be the longest side, right? Because that's the range. And in the middle side, you don't have to think about, because if you get the smallest and you get the longest, right? The middle side, if x was the middle side, it will be in the range of that number. Yeah? So if x was the smallest, then I know that x plus 10 needs to be greater than 12. Correct? Yeah? X plus 10 needs to be greater than 12 because 12 is greater than 10. If x was the longest, then I know 10 plus 12 needs to be greater than x. Oops, x. Let me write that again. 10 plus 12 needs to be greater than x. Right? Okay. X is the smallest side. X plus 10 is greater than 12. X is the longest side. 10 plus 12 is greater than x. So here, 22 needs to be greater than x. Here, if I solve this, I'm going to subtract 10 on both sides. X needs to be greater than 2. Right? Okay. So if I read this from left or right to left, it's x is less than 22, but it has to be greater than 2. Correct? So we're going to put these two inequalities together. I want to leave x in the middle, put less than signs on both of them. My low end goes here, my high end goes here. So x needs to be between 2 and 22. Cool? Yeah? That's what we're going to do with this, how to find the range. Questions? Simple stuff? Okay. So again, with B, you know what? Try B. Right? So pause the video if you guys want to do this by yourself. X can be the smallest, and X can be the longest, right? Again, if it's the smallest side, then the shorter length, X plus 14, the sum of the shorter lengths must be greater than the biggest, 21. If X is the longest, then 14 plus 21 needs to be greater than X. Right? Doing the math behind this, subtract 14 on both sides. X is greater than 7. Doing the math here, that's 35. Needs to be greater than X. So X is between 7 and 35. 7, 35. Okay? That's how it's done. Do you have any questions about this idea about finding the range of the values? No? Okay. So here is another theorem, another triangle theorem. Let's say, for example, I have one, let's say centimeter and 3 centimeters, right? They're actually not centimeters. I don't know why I put centimeters there, but I have 2 of these guys. Notice that this angle, is this angle bigger or smaller than this angle? It's bigger, right? And notice that if I make a triangle, class, if I make a triangle with this, be mine. It's better? Yes, it is. A little bit better. Go with this. Okay. That triangle, that third side's length, right, is 2, 3, 4 point like 2.5, 4.25. Yeah, 4.25. Okay. You guys see that? How it's 4.25? Okay. This side's length is 2.75. Okay. That side length is 5, so 4, 3, that's 2.75, right? So this has to do with the angle and the side opposite that angle. Notice that I made these 2 sides equal to each other. I just changed the degree of the angle, right? So that's kind of common between both triangles. So that doesn't matter, correct? The only thing that changes between these 2 are the angles, correct? So the bigger the side or the bigger the angle, bigger the side length is opposite that angle. Okay? The smaller the angle is, the side opposite that angle is smaller. Okay? Looking at these 2 relationships, right? So big angle, side opposite is big. Small angle, the side opposite is small. Okay? Questions on this theorem? No? And I wrote it in words here if you guys are so the side opposite the largest angle is the largest side. Okay? And the side opposite the smallest angle is the smallest side. And also vice versa. Okay? So we can say the side opposite the largest, or the angle opposite the largest side is the largest angle. And the angle opposite the smallest side is the smallest angle. All right? So if I want to, for each triangle, order its angles from least to greatest, okay? So this 10 here, the angle opposite this side is this angle here, right? The angle opposite this side is this angle here. And the angle opposite this side is this angle here, right? And they are all different in lengths. So I know 10 is less than 12, which is less than 15, right? So the angles opposite those sides have that same relationship. So I know that measure of angle C is less than measure of angle A, which is less than measure of angle B. Okay? Okay, so that's the relationship of the angles because this is the relationship of the sides. And now for number 2, right? Since 7 is less than 24 is less than 25, the angles opposite these side lengths have that same relationship. So 7, the angle opposite is E. That's us. What do you have in this time? You guys just stay quiet for a little bit. Yeah, I want to finish out these 3 examples. I honestly don't know where this was. So 7, 24, 25, that is the side lengths relationship. So opposite 7 is angle E. So measure of angle E is less than measure of angle F because angle F is opposite that side 24, which is less than measure of angle D. Fun fact, this triangle is actually a right triangle. Okay, so the next one is here. For each triangle, order its sides from least to greatest. So that relationship of the sides going to the angles is the same thing as if I have the angles and then I'm going to the sides, okay? So 30 is less than 50, which is less than 100, right? So 30 degrees opposite this angle is angle or side BC. So BC is less than, that's the smallest side because that's the smallest angle. 50, the side opposite that angle is AC. And the last side is 100. The side opposite that angle is AB. So this is the relationship that they have. Okay, from least to greatest. Here again, we have 20, 55, and 105 degrees. So if I label the angles, or if I, put the angles in their relationship, the side opposite these have the same relationship. So 20, the side opposite that is EF. So EF is the smallest side. 55, angle up or side opposite that is DF. So DF is the middle side. And 105, the side opposite that is DE, which is that. So this is the relationship. Okay. Hopefully this helps. I apologize for the last portion of this video. See ya.